So my two reactions were the symmetrical and unsymmetrical Ullmann arylation reactions. And shown here are examples of both of these reactions. The main difference between both of them are that the symmetrical reaction the substrate reacts with itself, forming this symmetrical product. And for the unsymmetrical reaction, we have a highly reactive substrate reacting with a not so reactive substrate, forming this unsymmetrical product. And then as for reaction conditions, we use a highly reactive copper powder for the symmetrical reaction to mediate that coupling, and then milder conditions with the unsymmetrical reaction. So we use copper salts and lower heat. So our typical substrate involves a halogenated benzene ring, and our most reactive halogen here is iodine, least reactive is chlorine. And then it is also advantageous to have an electron withdrawing group ortho to your halogen. And then whatever R group you have, and then obviously this is reacting with itself. Normally it's not drawn twice when you see it in a reaction, but I just drew it here for suggestive regions. And so for our unsymmetrical reaction, we have a highly reactive substrate kind of like above, though it's more advantageous to have alkyl groups coming off of here because that makes our substrate electron rich. And then we want our second substrate to be less reactive so that it can be mediated by the milder conditions with the copper salts. And so an example of the symmetrical reaction is we have this benzene ring here with the iodine halogen, and then we have our electron withdrawing group. And basically you can see if you just rotate this, they come together and they make a carbon-carbon bond where these iodines were. And so it is not exactly known what mechanism the Ullmann arylation takes. It either can form aryl radicals or there's the formation of aryl copper intermediates. And the latter mechanism is most widely accepted just because you can isolate those intermediates. So in the case of the copper intermediates mechanism, you would have an oxidative addition of copper to this iodine right here. And then once that copper was added, then it would have another oxidative addition to this second substrate, and then a reductive elimination to form the symmetrical Ullmann arylation product. And so for the unsymmetrical Ullmann arylation, we have a highly reactive electron-rich substrate. We have our iodine, we have our electron withdrawing group, we have a bunch of alkyl groups all coming off of here, and then we have this less reactive benzene with just a bromine coming off. So we use these milder conditions, and then we form this unsymmetrical product. And it's kind of obvious that it is unsymmetrical because we have two different things where these two halogens once were. So if you want to test to see if you can tell the difference between symmetrical and unsymmetrical Ullmann arylation reactions, we can look here and see if you can figure it out. So if you pause the video, hopefully you guessed this is a symmetrical reaction because we have the bond where this iodine was over here. And then if you just rotate this and then flip it over here, you can see that it reacted with itself and there's no other substrate. So even if you did think it was an unsymmetrical reaction, I don't know where you got that from. Okay, that is it for the Ullmann arylation.